Hey everybody, it's Average Drafter. We're going to take a look at the MultiNode plugin. This is a plugin that I created in about a week and a half with Claude. This is our 0.2.0 alpha, open alpha. I am very much in need of people helping us out to get this up to uh, standards. I want to lock down the APIs so people can actually start using these in projects. For now, this is for evaluation and for people to give feedback, and I will probably move it up a version once it's ready for people to actually use in projects and we get the APIs locked in. But for now, this first release is just going to be a open alpha for people to evaluate and to use and to make suggestions and features and try to get them some things locked down. So what it is a compositional instancing system. Essentially what it does is it takes a multi-mesh from Godot, the multi-mesh node, and divides it into two components. The multi, which is the instancing information, and then the mesh, which is the mesh information. And then it puts the multi into a parent node, and then the mesh as a child node of that parent, so that all the instance information is in the parent node. The mesh just has to care about the mesh, and the mesh will repeat for the instancing information. So with the parent node and the mesh, this is essentially the same as a multi-mesh. But what this lets us do is not only add more meshes to the multi-mesh for the instance, also lets us do collisions, animations, audio, particles, anything that we made a node for, and we made a lot of nodes, pretty much anything that made sense, we made a node for. So um, a lot of these nodes have been tested. There's a demo that comes with the plugin that has all of these different nodes demonstrated on them. Some of them are less developed. The animation one needs an editor. The particle systems has not been terribly developed, but it is working. Decals seems to be working, but I don't really know how decals work, so it's hard for me to say. But it definitely seems to be able to stamp things on and then or have things on its surface. Um, but raycast areas, all these work. It's just a matter of developing so that they're as usable as possible, as functional as possible, and I definitely could have need some help doing that. So let's jump into it. Very first thing you want to do is download the zip. Let's open her up. Okay. Here's the add-on. Let's go ahead and get a Godot project started. Okay, let's get a Godot project started. MultiNode.live demo, create. Here we have the extracted plugin file. So from downloads, we extracted this. We have all this information. The only thing we really need here, though, is the add-ons. So we'll just drag the add-ons over here. Go back to the editor. Give us a... Okay. So here is the multi-node. Think, yeah, it should be ready to go. Enable, close. Go ahead and restart the project just to be on the safe side. Okay. Get a 3D scene going. MultiNode live demo. Just a normal scene. We'll add the MultiNode. This is the root. These little purple dots are the root. All the tools that work with the root have the purple dots behind them. That's how you can tell they're meant to be worked with inside a multinode. Add the multinode. We'll call this the scatter. All right. So what the multinode is going to do is be in charge of all the instances. And right now we don't have an instance limit, so we can use this to limit the number of instances, but we don't really want to do that. We want to use transforms. This is going to be default, and almost all the time this is what we're going to be using for our node multi-node. If for whatever reason you don't want to have XYZ rotations and linear and rotational velocities are what are by default saved as an instance. If you don't want those as and you just want an index for your instances, and you can turn this off. That's just for like, I don't know, like simulations and things like that can use a node system like this. But that's not really what we're looking at right now. So we have the multi-node scatter here. We are going to add to this, either add this way, or we can add down here. We have a lot of the subnodes. Add an instancer, and a mesh, and a collider. So for the mesh, we are going to make it a cylinder. Materials are going to be, where are you? There you are. Standard. We're going to make you orangey, and that's fine. We'll make you a little bit more orangey though. Yeah, that's nice and orangey. Okay, orangey cylinder. The standard height is fine. We'll add a cylinder shape here, and we'll keep the same, the basic settings here. So we have a cylinder and a mesh. So we have a mesh and a collider, but we don't have any instances yet. So what we're going to do here is go to the instancer. There's an array mode, mesh fill, and manual. Array and mesh will help you generate a mesh. Manual will let you manually select different instances and move them around based on that information. But right now we're just going to worry about an array. And I need to work on the UI a little bit. It should decrease the number as I decrease the number here, but we have to manually do that. That's something I'm going to fix pretty soon. So we can clear and regenerate. And then if we want 5, we can clear, regenerate. But as it goes up, it does add more. It just doesn't take any away until you clear, regenerate. But that's something that we can fix soon enough. And then we have rows and columns. And then that's how you get a 3-dimensional grid. It goes by just however many rows and columns, and then the spillover will keep on going. So with 3x2, 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 let's 3.5 to give a little space here. 2.5, 2.5. Okay, so and every one of these instances now has a mesh and a collider. This isn't just a mesh, which is a big feature to add. Most multi-meshes obviously just have the mesh. So this is the multi, this is the mesh, this is the collider. This instancer, once we have this array, we can delete it. And I don't want to delete it because we're going to use it to adjust our instances and keep generating more until we get what we want. But right now, what we want is 500. There we go. 500 instances. Now, we don't want them like that. about a nice stack of 5x10s in an array. And this array is obviously going to be very similar to anybody who's used Blender. Very similar array tools. So we'll turn on follow rotation. Actually, we'll turn it off at first. And then if you see like one, and you can see the effect that it has on the rotation. And then follow rotation. You can see the guys rotating in place, and then you can see them, each one sequentially following the rotation of the one before it. And obviously big changes here. Multiply, you just do 1, 1, and 1. Everything has a little bit of change. Let's do 10, 10, 10. And you can kind of see how all that goes. And then you can apply a scatter. And then we'll do a little bit of a jitter of 1, 1, and 1. And now we've got this nice jittery, scattery arrayed instance, multi-node mesh and collider. And these do have substance. We will show that in a second. But before we can do that, we're going to add a camera. And then we'll pull back the camera. We'll pull up the camera. We'll select the scatter. We'll move it over. The camera, move that back. Am I missing something? Oh. Okay. Down, over. Gotta just pan back a little bit, maybe go up. Maybe we'll change this. Array a little bit here. Where are you? There you are. Right, 15. Gives us one extra row. Anyway, don't have to be too terribly exact. It's just a scatterer. And then let's take a look at the camera. It looks pretty good. Do some adjustments and get a nice view of its scattering. Okay, so that's going to be our scatterer. And that is one multi-node. Solid cylinders made by instancing a mesh just like you would in a multi-mesh, although they don't have an instancer. You have to do that in script, which you can do. Obviously, if you check the documents, you can find all the scripts, methods, and all that kind of stuff that you can do for scripting. Add another multi-node to do the drop. And that does not belong in here. That belongs under you. Okay. All right, multi-node drop. Let's get the drop going. So same thing. Add a mesh. This time before we add a collider, we'll just go to the mesh. We'll do a prism. There is not a standard prism shape, so we'll use this opportunity to do a convex collider. So you can use it with any mesh. and you have a collider for any mesh, but we'll show you that in a second. Let's get the color set up. Do like that, and we'll do an alpha right about there. There's going to be a lot of them, so they'll add up. Okay, so yellow alpha, and then at the bottom here, we have convex Tremis box. We'll go with convex. So there's the collider. Change this to a rigid. These guys are it defaulted to static. Self-collision, I don't think has any effect on static. It might. We'll see. But it doesn't really need to be here for static, but it does for rigid, and they do self-collide. So these guys will collide with each other. Mesh and collider. Okay. So we have a mesh and collider, but we also want to add one more thing. Let's add a light. Okay. And then, actually, before we add the light, let's go ahead and get our instances going so that we can see the light happening. So here's the instancer and the node tree instead of using it from here. Okay. Every instance. And this time we'll do a mesh fill. We'll do a sphere. Surface cover, we'll just do the surface. Fill volume, we'll do the fill. Scatter, enabled. Jitter, 1, 1, 1. Random rotation. And let's get 500 of these too. Now you can see they're all down there. Problem is that they're all crammed into a very small mesh. So let's alleviate that problem. Actions, clear, regenerate. All right. So now we have the translucent prisms in a big ball, round. These guys are rigid bodies. These guys are static bodies. Let's get these on top here. Oops. Moving the instancer. We need to move the drop. The MultiNode drop. All right. But before we do that, let's get this guy a little wider. That'll work. I guess that didn't really do anything. Let me see. Let me mess with these rotations a bit. Get something going. It's a little less compact. There we go. Chaotic but uncompact. All right. Get that scatter over here. All right. 500 scatters, 500 drops. All right. So in addition to the translucent mesh, turn that on. Yeah, gorgeous. So let's, in addition to the translucents on these guys, we're going to add a light. Oh, beautiful. But a little too much. So we're going to do it every 10. Okay. And then we're also going to offset it. And this might change. I don't think it's hooked up to the transforms here. I don't think this actually does anything yet. But right now we have this offset, so we'll do an offset of -2, which will put it 2 meters above. we wanted to do 10. You'd see it really move, but, no, is that 2 up? Well, however it is, it's offset from the main. All right, so we have a light that's offset every, what was it, 10? Every 10 instants. Again, if you want to make it more intense, you just add more lights, or you can change the setting. So that's 0 is off. That's 1 every, again, this is additive, so as you get more and more lights, it adds up to more lights. So we have 500 lights here, 250 lights active. So we'll do it every 5. Nice glow. All right. So I think we have everything ready for our first drop. A little stray guy there. That's fine. Save. Play. This is our current is our main. And there we go. Lights following with their instances. This is all, the multi-meshes are not nodes, individual nodes. These are just one node per mesh, per collider. One node per mesh, per collider. So the way that the colliders work is that it injects all of the collision shapes into the physics renderer at the same time, much like how the mesh gets injected into the graphics processor renderer at the same time. It sort of works the same way, but a little bit different. But essentially, that's how it works. It also batches them all together. So all of these cylinders get put into one call. All of the prisms get put into one call. And that's how it processes the colliders. It actually doesn't make it an absurd amount faster, but it does save a lot of overhead from the Godot node system. All the nodes are made in C++ and compiled, so they are fast in GD extension. So that is the live demo. I think that gives you a good idea of how all this works. Now let's have a little fun. In addition to the live demo, there is a pre-made demo here, demo scene. You can open the scene, and it has a lot of fun stuff that we can play with. So let's just go ahead and run it right out the box. Oh, sorry. Run this scene right out the box. All right. So let's take a look at the platforms here. These platforms are kinetic colliders. They are based on an array. That array was given animation. These are all using the same animation track, but there are staggered points along the track. The animation track had to be built in script because I do not have an animation editor. You can either build it in script or you can build an animation in the Godot animation editor, but you have to make like a player first. I very much plan on making an editor very soon, so that editor will work specifically with MultiNode. Also, am planning on making bones work with the meshes in MultiNode, and with the animator and the bones, you should be able to have the different instances in different states of animation, as well as just different states in general, because you can also use the animation as, once I make the changes that I'm planning to make, you can use the animator as a state machine. State machine, tweener, and animator, all in one and kind of simplified. So that's where we're heading with that. But for now, let's take a look at the demo. 500 count, one mesh, one collider for the cubes. We have a sphere mesh, a capsule mesh, and colliders. We have labels. Let's take a look at the labels. You turn the labels on, and you can see labels. You can see it's a little bit, rough here. There we go, one. So when you're maneuvering around, you have camera movement. I'm using right click and WASD to move around here. So you have that going on. If you push shift, you get a sprint on that. So you have labels here. I have a script making all these labels show their instance numbers. So just like the every nth on the lights, we can do every nth on the labels. So every sixth label shows its label. or every sixth or seventh instance shows this label. Every 10th one shows this label. Okay, so that's one. Let's see, audio ambient. Um, to be perfectly honest, I'm not sure if the audio is working right now. Let me see something. Yeah, I don't know if that's recording or you can't hear it or I can hear it, but let me just turn that off. And I'm not sure if I just can't hear it through my headphones or what, but I'm not hearing any sound. So if you heard a bunch of noise, you probably heard a bunch of noise. If you heard that, I'm sorry, but that's the audio. So the way that the audio works is that it is 3D audio, uh, but and it has a source for each one of the instances. There's an audio source there, but uh, the node will combine all those sources before it sends it to the Godot uh, audio channel. So it'll take all of these instances of audio and mathematically combine them before it sends them to the one audio channel in Godot. So I think that's a really useful way to do massive 3D audio with the same sample or wave or whatever. It has to use a wave to do it, but it will combine all those waves for each one of these instances. So you get ambient noises from each one of them. You can get a notify on the raycast for each one of them. And then let's take a look at the raycast without any sound. So the raycast is essentially a spring on the bottom. Um, there's a cooldown for 3 seconds, I think, and I think there's a minimum number of springs that are allowed to be active at once. So that's why you see all this scattering. But that is a raycast on the bottom, activating a force on the box up in GD script, but using the raycast node subnode here. So as you can see, there's scripts on a bunch of these nodes that are used for running the demo. There's scripts on here that are used for running the demo. There's scripts on the scene that are mostly used for the camera. And there's a script on the platform animator, basically to build the animator. And these are typical normal colliders for the floors and stuff. And that's pretty much all that's in the scene. Um, Everything else is being ran as you see it, just using the multi-nodes to manage all this stuff. So that's a lot of fun. Let's take a look at when we turn area one on. And they all turn into, not only do they turn into spheres, but their colliders also turn into spheres. So there should be some rolling here in a second. If not, oh, they're not rolling because of the raycast. By the time it hits it, it bounces. So let's get that going, and you should start seeing some rolling. Yeah, there we go. Rolling, rolling, rolling. All right. But the area doesn't turn them into spheres. What the area does is it turns the affected uh, instance into a sphere, or the central area located. So there's a box around each one of these. The central one turns into a sphere. Anyone that's caught outside of it that's not already a sphere, oops, set back to 0, will turn into a purple capsule. So let's take a look at that. We go to area 10, so only every 10th of these is going to be a sphere, and then you can see what happens to everything else. All right. So you have a lot of spheres. If a box is near a sphere, it turns into a capsule. If you want to see that in action in a very dramatic way, let's reset by pressing enter or space. There we go. Lots of capsules, lots of spheres, lots of boxes, and you see as it moves away, it'll turn, it'll move closer, it'll turn, turn to turn, turn. Cool stuff. All right. Even more cool stuff. Reverse gravity. Let's just go here. Reverse gravity is a shader program. Shader programs are allowed on any node, but they attach to the multi-node sub, which is kind of the root for all these subnodes. It basically gives all the information to say, hey, I'm a subnode for multi-node. And that is the level where you get to attach shader code. So I have a reverse gravity shader code um, that also uses the GD script here to reverse the gravity for every nth node, nth instance. So for fun, let's take every 10th, which would be the same as the area, which makes all of these green balls move up. There goes the reverse gravity. That's why we have a ceiling up there. Okay. And you can see some of them are trapped, some of them are fighting. There's probably one underneath all these capsules. But let's watch it. Let's watch a fun demo here. Balls go up, boxes go down on the way they turn into capsules. By the time they separate, they're no longer capsules. They separate. Just a fun little thing that, just playing with the nodes. This is kind of how I built and tested all the nodes using this tool. And it's more or less as it is. I think that the FPS is a little off because once you start using the area, it just doesn't seem like it's accurate. Like this doesn't look like 20 frames a second. It definitely doesn't look like it's moving that slow. And it doesn't really get above 30. I think it's something going on with this over here, so you can't really go by that. I'm sure everybody will have their own benchmarks that they can use. But from the benchmark of just going by a multi-mesh and a batch created collider node system, like you would normally be doing for Godot without any plugin, versus the multi-node with a mesh and a collider, there is about a 10%, I would say, improvement with the multi-node, with the multi-node mesh and the multi-node collider versus the other system. But more importantly, there's just a significant structural improvement. And I'm looking to optimize all these nodes. So right now, all this is running a little bit better than if you were using nodes. And that is mostly coming from the collider batching and basically skipping the nodes, the Godot node system for injecting the colliders into the physics renderer. We are losing a little bit on the area because of scripting in the demo, basically, which I'm sure I'll bug hunt at some point, but I'm not particularly interested in bug hunting the demo if it's going to delay getting the nodes out, which it would. So again, the raycast is basically a spring. Raycast every 1, raycast every 5. We already saw how lights work, but you can see all that going into effect. Particle systems have not been too terribly worked on, but I just wanted to make sure it was functional. So we got that every 1. You can definitely see the slowdown, which makes sense because it's projecting a bunch of spheres. So let's do this every 15, and you should see it speed up a lot. And we'll go ahead and take a look at these. But yeah, every 15 is now shooting orange spheres out of the top of the box. And that's fine. We can keep that going. That is an acceptable frame loss rate. And again, this doesn't look like 22 to me, but maybe that's just me. It looks like 15. So you can see the particle system, the decal. I'll just show you that real fast. Just stamping a bitmap PNG file onto the bottom. You are able to change and adjust that, as a normal decal. I haven't really messed with decals before, so I don't really know how much it works, but I just wanted to make sure that it does work, so it does. It's stamping onto the bottom of whatever underneath it, so we can just turn that off. And then sprite. This one's one of my favorites. Right now we have a sprite. Let's get this on every other guy. Okay. And the idea is that it will run with the linear velocity and slow down the slower it gets, and if it stops, it'll stop. But something broke in the demo, and when they're stopped, they're still running. I'm not sure exactly why, but you can see that they are animated sprites per instance. But you're able to control again, how many nth. But the performance is not really hindered by having a lot of sprites out. It's, you know, uh, that brings up a good point. This is mostly a 3D tool, obviously, but you could use this for 2D. You just have to limit the Z in 2D mode. But again, this is an alpha to get some feedback and to get people experimenting and testing it. Um, yeah, it seems like something's going weird with the colliders here. Let's reset this and see if there's something that we can look at. But testing and tweaking and finding small issues that we can deal with and stuff. That's not really too big of a deal. I just want to make sure that this gets out, people start using it, so that we can get a solid API locked version and people can start using it for actual projects. Because this just looks like a fantastic tool for a lot of people to use. Let's get these guys back down. So anyway, I'll just leave you guys with a little bit of a nice show here. Um, and that's MultiNode. I think this is an incredibly powerful tool for Godot. I think it does some things that um, Unity doesn't even do. I think it has the potential to develop into just a standard tool for Godot. Um, and I'm really, really, really excited for people to try it out and give me their opinions on it because I'm been having a lot of fun with it. So thanks for watching and let me know what you think and let me know about feedback, any opinions or optimizations or feature requests or anything like that. Let me know. Um, and check out the Discord and the Reddit post where I'm posting the Alpha 2.0 build. So I appreciate you watching. Thank you.